Okay, so in this video, we're testing a used FSPN26 unit from Rohde Schwarz. And what we have is a signal generator that works up to 20 gigs connected through a splitter to both the FSPN26 unit and an HP8564E spectrum analyzer, just because this thing doesn't have a built-in spectrum analyzer function. That would be the FSWP unit, right? So from the signal generator, we're at 4 gigahertz, and we can see the output is there, so we know that this thing is working. And on the phase noise analyzer, we can see the 4 gigahertz signal coming in at about minus 19 dBm, when it's doing its measurements. Now we can go up in frequency to 8 gigahertz. Just give it some time, and there it is. It found the signal and all is well with it, doing its measurements as usual. Now the problem I found with this unit is that we can't measure anything higher than 8 gigahertz. Okay, so what I'm going to do is I'm going to go to 8.1 gigahertz. Okay, I'm going to see that on the spectrum analyzer, and we're going to go over to the phase noise analyzer. The issue is it's saying it can't find the signal when we know that it was able to do that previously. So what we can do is maybe try 20 gigahertz, because that's all we can do with this signal generator. But obviously this phase noise analyzer can go up to 26.5. So still the same problem across that frequency range. So what this kind of tells me is that this phase noise analyzer unit may be operating in perhaps a frequency limited mode by the software. I know that Rohde Schwarz offers the FSPN8, so that 8 gigahertz frequency cutoff does make me a bit suspicious. So let's go back to our 8 gigahertz signal, and we're doing the measurements again. It found the signal with no problem. Another thing I've found is, well, I actually set the amplitude such that we get a minus 19, almost minus 20 dBm exactly signal here of the input. So the issue is that when we go in the amplitude and we say maybe reduce that just a hair, so I'm going to do this with the knob, and at the same time show you the screen here. Okay. So we're going down slowly in power. You can see the power changing there. And it loses the signal. Now it depends, it's because it was running for quite a while with minus 20 dBm actually making it to the unit. But what I've found is depending on how you start it up, if you don't actually give the unit some time at minus 20 dBm, that power actually does cut off sharply at minus 20. That's not necessarily a problem. I just wonder why it expects at least minus 20 dBm to operate and make the measurements. In any case, the bigger problem right now is the frequency issue. So just to be clear here, we could go for a 0 dBm signal, just to be completely clear. So we're at minus 6 dBm on the unit. Sure, let's just okay, there it is, 0 dBm. So we just did the signal generator to give us 0 dBm here. Now the question is, when we change the frequency to 8.1 gigahertz, does that fix the problem? There we are at 8.1 gigahertz, and it can't lock on to a 0 dBm 8 gigahertz signal. So you can see there, so at the spec A it's about 1.5 dBm at 8.1 gigahertz. Over here it should be at 0 dBm, just based off of what we were doing before. So let's get this down to 8 gigahertz, and we can see peak search. Okay, 8 gigahertz signal, 1.3 dBm. Over here we have the same 8 gigahertz signal but at 0 dBm, and the device is doing its measurement. So I think this test really does show that the unit has an issue with making a measurement anything beyond 8.1 gigahertz. So there it is again. I think we'll be asking Rohde Schwarz to have a look. Thanks.